For more than 25 years, the Mesa Model Railroad Club, located in the San Diego Model Railroad Museum in Balboa Park, has been building an HO scale replica of the railroad between Bakersfield and Mojave through the Tehachapi Mountains. To date, almost 28 scale miles have been built. The railroad climbs from 33 inches above the floor to 170 inches above the floor, which represents 990 scale feet. 60 car trains are regularly run over this mountain, complete with helper engines interspersed throughout the train. On special operating sessions, even longer trains have been operated. Mountain railroading is difficult for the real railroad, and it's no simpler in the model. It requires careful consideration and detailed construction of the rolling stock in order to make this possible. This video is an interview with Car Department Foreman John Cathcart, who shares his information on how to build rolling stock for mountain operations.
So I'm John Cathcart. I'm the Car Department Foreman on the Mesa Model Railroad Club. I've been the Car Department Foreman for 40 years. And when we were in La Mesa, I was the Car Department Foreman.
How many cars do you think you've registered in your life?
Close to 10,000.
Wow. So what's our total registration count these days?
Our total registration count is really, now it's around 6,000. We start with the gauging wheels. We're using an NMRRRC gauge which is designed for the RP25 wheel contour, but since the manufacturers have taken upon themselves to improve that wheel by narrowing the flange, how do you gauge a non-RP25 wheel with an RP25 gauge? We're not so much worried about any difference there might be in the contour of the actual flange way, but we're more concerned with the fact that since they've narrowed the flange, they have changed the gauge, narrowed the gauge. So what it means is when you take a modern wheel set now and put it in an RP25 gauge, there's going to be some free play, some slop. You can feel it more than you can see it. You need the most play that you can get in there, wheel against the gauge, because the wheel must be free to travel the full limits of that gauge, because a regular NMRRRC wheel would fill the whole thing. So this wheel, whatever wheel you put in there, must be free to move and freely occupy all of those limits. And our true RP25 wheel is going to drop right into these two notches and fill all of that space up and have no movement whatsoever, and that's either a go or no go gauge for an RP25 wheel. But unfortunately, nobody makes an RP25 wheel anymore. It's all what we call here a sub RP25 wheel. It's finer than an RP25. They've narrowed this flange way. They've left the tire width the same, which this doesn't check that anyway. But the no-go portion, square corner on your gauge, checks the total width of from the back of the wheel to the front of the tire, including the thickness of the flange. So it's all one thing. If the wheel drops into here, technically it's a no-go on a railroad. That's what it says right on there, no-go. If it doesn't drop in there, it's good, if it fits these two notches. Now, with the minus wheel, the thinner flange, when you put it in here, then because it's the thinner flange, you're really trying to check the gauges, the two center points. So these things should be in the center. Well, how do you find that? If you have a wheel set, it's all the way over to one side here against this edge. The corresponding wheel should be against the corresponding edge on the other side, and vice versa. If you move it the other way, it should be the same thing. These distances all being the same, it's the same as when you line it up in the center.
Right. So if it was a wide gauge,
so if it's a wide gauge, they're both going to be on the outside. Both be
and if it's a narrow gauge, it would be on the inside, and it still fit in the gauge, but it's not really gauged right.
Right. And also, if it's anywhere in between, there'll be some slop. But what you in fact want is maximum slop, because maximum slop is check gauge, which means when it's against this edge, against this corresponding edge, if it's against that edge, this one is against that corresponding edge.
We know now how we want to use the gauge. So when you get a new axle set, what do you do?
Okay.
What's the first thing you do?
First, you have to start with a gauge that is known to be good. Here that's easy because we always have gauges that have been checked against each other. So if one is dropped or sat upon, we have one we can compare it to. And just because you bought it at the hobby shop doesn't necessarily mean that it is. It probably is, and I've had very few bad ones. But when the bad ones appear, they're all bad. We had that happen a few years ago. And
There's a whole batch of them that are not
the whole
spec.
batch for like a year, and all the hobby shops everywhere was bad, and they had to redo them. And so the ones that are out there now are good. I don't know the current model number. I think mine is a Mark IV or something. They may be on a later edition of that. But so take a good gauge. Should be new from the NMRA. Would be good to compare it against someone else's that doesn't have a problem with their equipment. When you check the gauge by putting the wheel in there and moving it, see if there's any free play, you can feel it almost better than you can see it. The thing to remember is you want to feel the maximum movement, as we mentioned before, so that the wheel is free to move within the full range it should. They'll tell you on anything you read on gauging wheels that you should always rotate the wheel, the axle, and check it in the gauge on quarters every 90 degrees. I will tell you emphatically that that's not good enough. You need to, I tell people to check it on 16ths.
That's to make sure the two wheels are actually parallel to one another.
Actually parallel and square, perpendicular to the axle. So that's what you want to determine for sure. And the other thing is you can actually roll on a good tabletop or a piece of glass, you can roll the wheel and watch it. If the wheels wobble, it means one or both is crooked. If the whole wheel set rolls crooked off to the left or right and not in a straight line, it means you have two different diameter wheels, and so you need to scrap that puppy. Now the other thing you have to watch when you do this is you have to watch for distraction. Your eye will be distracted. There's a chip on here. Now you see this chip going around.
Yeah.
That'll draw your eye to it. And so then you may be tempted, or if you see spots, dirt, paint, or reflections on the wheels as they roll, you might think, oh, well, there's a defect. You have to fix on something like the wheels to see if they're wobbling, the axle tips to see if they're going up and down. If you're not having any of that, you don't have a problem. If you have an up and down motion of the axle, that means that the wheels aren't true, and there's really no way you can fix that without replacing a wheel. You might as well replace the wheel set. But if you have a little wobble and one wheel is not quite true, it can be fixed. But there again, you need a tool to do it. You need a jeweler's anvil or something. I use an old flywheel that I can pull one wheel off and stick it in the flywheel, and the flywheel has got square perpendicular surfaces, so I can hit it with a jeweler's hammer or with another flywheel and straighten it out. I like to see them as good as you can get them. I think people that are willing to accept it will say, yeah, well, it's close, it's not perfect. If your goal is not perfect, it's kind of like, why are you even doing it? I mean, this is a mighty small thing here. You're talking way less than 0.1 of an inch to be good and crap. So make it as good as you can get it, and you're only going to get that way by practice, and like I say, more by feel than by vision. If you're going to do by vision, you're going to need magnifiers, a white bright background behind it so you can see what's happening there. And because you see one flange move against the limit of the gauge, don't forget to look at the other one and make sure it's in the same relative position. If it's not, you're not gauged right. So this is what I do. I start down here and come this way. When it hits that corner there, that right there, that's a caution, right? If it hits that corner, it really should be rejected. If you're
It's a little narrow then, because
little
it's hitting
narrow.
the corner.
Yeah,
Because you've got the lower flange against the lower edge of the lower notch.
Right.
And the upper flange is hitting the lower edge of the top notch.
Right.
Okay.
So
All right.
that's a little bit snugger than we would like to see it. There is movement. You can see there is movement.
Yeah.
But we want the maximum we can get.
Right.
What I do, take the wheel out, twist it just as though it has threads. It has none, but you get the most physical force that way. Push it in or out as you twist it to get the desired effect. Widen or narrow it. Put it in the gauge and see what you have. Now here's wide gauge. Both flanges are against the outer limits of the gauge. The wheel doesn't move. That's incorrect. That's wide gauge. So now I'll twist and push it in until I get it to the point where it's neither against the outer limits or the inner limits. I'll adjust it till I get maximum movement. If I'm not sure if I have the maximum movement, because when I look at it, one wheel's not against the limit, I'll just move it. If you don't know which way to move it, widen it. If that didn't work, then you know you have to narrow it. It's the only way left. And so get it till you feel visually and with your fingers, you sense a feel that you have the most movement you can get in the gauge, and that will be proper. Okay, once we have the wheel gauged, you want to look and make sure that the axle tips are not damaged. If you've just gauged the wheel, you want to, wherever your gap is, could be on both sides or all on one side, doesn't really matter, but where you have any gap in there at all, air gap, you want to fill that with super glue. Not that it will necessarily glue it, because if you have a, say, a Delrin axle, it won't, but it'll fill the space and not allow it to tighten up again.
Mm-hmm.
And if you use the right kind of super glue, it will glue to Delrin also. So you, at any rate, you want to glue the wheels on the axle so that
But that's just
not
more
gonna
like a
move.
mechanical filler.
That's a mechanical,
shim in
that's
a way.
exactly what it is. It's just to keep that from moving, and the glue will pretty much keep it from moving either direction. Once you've determined that you're happy with the gauge of the wheel and you've got it glued up, then put it back in the trucks, and you should spin the wheels in the trucks and count how many seconds those things will spin. Now, this is a pair of Kato trucks, or Kato as everybody calls them, and they roll probably better than anything. Very few things roll better. These will spin for 30, 35, even 40 seconds if you do a good job setting them up. Certainly the minimum time you want any wheel to spin in any axle is going to be at least 20 seconds. That corresponds to about somewhere between a 1.5 and a 2% grade. If it spins 30 or 35 seconds, that's getting below 1%, so that's good. If it only spins for 10 seconds, you're looking at 3%. It's not good enough for our railroad. So you don't have to have a dead flat with a grade block and a grade track, which I do have, and I can show you that later, but basically the spin test is the best. I tell people, well, how hard do you spin it? Well, you spin it as hard as you can, Look at your watch when you kick it off, and you can time the seconds. We'll see how we do here. I think I said 20 seconds was a minimum. Well, we're doing good here. It's about 30 seconds. So, yeah. Now, if it doesn't spin, there's a couple of cures. There's a special tool which we have. You can remount that journal. A lot of people swear by that, and it's probably the best theoretical way to do that. However, since it's basically a machine cutting bit held in your hand, and you have to apply surface to both sides of the truck to get enough bite to actually do any cutting, and you're turning it with your finger, you have almost no mechanical advantage, and your chance of doing any real cutting is not very good. You can do it, but if you're dealing with engineering plastic like this Delrin, you're not going to do much, and it's going to take you a long time to do it. I prefer to just bend the side frames of the truck, because we're only talking thing on the order of 10,000ths of an inch here. Now, you'll have to bend it more than that.
Yeah,
I would take this and tweak this quite a bit, like that. Now, the reason I do it, and I'm doing a little bit overemphasis here, you probably don't want more than 10,000ths or so, maybe 12,000ths total difference. So you want to do it over both side frames, because you're trying not to parallelogram them, but like I said, the wheelbase is so short it probably doesn't matter if they do. But you have to remember, since it's plastic, and especially in the case of like the Kato, it's Delrin, plastic has a memory. Anything you bend in there, it's going to lose probably 40 to 50% of that overnight. So you want to be overbending it. So if I'm looking for 10 or 12 thousandths overall, I'm going to tweak that Delrin side frame pretty good, because, and what's pretty good? Well, maybe 20 thousandths, enough that I can see easily. You could see it if I did it. Because it's going to go back. It's got that memory, and so I'll check it tomorrow when I come in and do the roll test again, or the count test on the spin test, whatever.
Right.
So just try to adjust them both so that it's out of there, and try to do them so when you look at it, you don't have one like this and one like that. You want it so you can barely notice the two have been tweaked. You can see, well, it looks like maybe they're separated a little bit. That's what you want to see. And of course, the real test is put the axle in there, spin it, see does it do the 20, 25 seconds, 30 seconds, whatever your goal is. And that'll take care of it. Do the day after test and make sure the memory hasn't brought it back too much, and it'll be good forever. I tell people, they say, what do you use for lubricant? I tell them, if you don't have to, don't use anything. Certainly on a Kato, you don't have to. You're only going to detract from the rollability by messing with it. The cut those road really great.
Now, if you do lubricate, you use a Teflon?
I do, and I've tried a lot of lubricants. I know that KD and others do sell, for example, for their couplers and their trucks, graphite. Graphite's a very fine, standard, old-fashioned, as well as space-age lubricant, but really it doesn't work on anything they sell because graphite was made to be held into the pores of metal, typically bearing surfaces or cast metal, Zamac and like that, and all of their stuff it's anodized, so there are no pores exposed. So not only does it not get held in place by the metal, but it just fluffs away. It's so light. There's nothing to hold it there. I use the Elmer's Slide-All Teflon. It's made by Elmer's, but it's really hard to find. But I find the places that consistently have it is lock shops everywhere tend to have this. I like it because it goes on liquid. You can't really spray it. It's designed to be sprayed. I wish it was brush application because our things are so small you can't spray this in there. So what I do is I spray it in the cap, and when the can goes empty, I save the cap because it's got the residue. Because you can put any kind of evaporating carrier in there. You could use MEK, provided your trucks won't be affected by it, and liquefy this and apply it. Typically what I do is when we're going through cars and we have to lube stuff, we have whole parts of our fleet that have to be lubed because they're really old and really worn. We take all those wheels out. I lube all the journals in the side frames, all those holes in the side frames. It takes about 3 passes with a dedicated brush, and I say dedicated because if you use a regular paint brush, you're going to ruin it for painting and you'll ruin it for Teflon. So use a dedicated brush. Shake this up good, especially on first use. Spray it in the cap. Paint the journals. You have to typically do them 3 times, sometimes more, but the typical journal takes 3 drops. Put 1 drop in, go around, do all your other journals, come back and just have a pile up there and go in a circle so that by the time you go around in a minute or 2, the first one you did is dry, you can give it a second coat. It takes about 3 drops or 3 coats to get a noticeable residue. It's not quite dry. I'll see if it looks like it's mostly evaporated. Then I'll go ahead and start the next drop. This one you can see it's dry all the way inside. I don't know if you can see that one.
Now, do you put the lubricant on the ends of the axles too, or just in the pockets?
So I found it's a waste of time to put it on the ends of the axles. And once we get to the point like this where we're starting to get the white, I don't know if you can see that, the white inside the pockets, inside the journal holes.
Yeah.
Once those are coated and dry, then I'll put the wheel in. And then anytime I have too much residue on the outside, I just get a toothbrush and brush that off. So this is a good product. They don't pay me to say that, but I found it's what works for us. I've tested other Teflons. I've tested $30 a can Teflon aircraft stuff. It worked almost as good, but took 4 times as long to dry. This dries in a minute or 2. Well, I'm going to just mention rollability the way I do it, even though I already told you about spinning the wheels and counting the seconds, because everybody can do that. To set this up, like I say, you need to have a bullseye level where you're on the inner range of the bullseye, your bubble is, any place within where that test track is going to go. Once you have that, and this is probably the only spot on my desk that'll do that, is why I have it marked. Once you have that accuracy where you're within the inner line, and that's as dead flat as you're going to get it without having some kind of machine setup, then that's good enough for a rollability test. Well, you're going to need a test track 100 scale feet long, which is what this is. Then you need to make some grade blocks that are 1 scale foot thickness. This one is not quite. This one has been thickened to 1 scale foot because 1% grade is defined as 1% rise in 100 scale feet of length. So that horizontal length, 1 foot, that's 1% grade. So on our railroad, we don't accept anything worse than, I'm going to use a penny for a half a scale foot. It's not quite, but it's close. 2.5%, which looks pretty steep here, actually, is the poorest rolling standard we would accept for a piece of equipment. generally. Now you can see this rolls like gangbusters on that. I mean, it's just going to. And the definition for our rollability is it must initiate spontaneous rolling from stop for at least one full body length. Well, one full body length was if the rear of this car rolls to here, it's done that. And it's, you know, it's derailed. It's got one wheel on the ground, so it's pretty good. So, but you can actually get, and this car may do it. It's got the right trucks, but actually I haven't finished blueprinting the car, so it may not do it. But a lot of these cars will roll on less than 0.5%. This is the Kato trucks, or Kato as you want to call it. That's less than 0.5% grade. And that's a perfectly acceptable rollability there, because it rolls more than a one car length. It did it spontaneously. I mean, it doesn't count if you have to start it. Because if you have to start it, that means you've got a flat spot or a piece of glue or dirt on the track or something. So it's just initiate spontaneous roll, go one body length.
So your no-go, if it doesn't do it on 2.5%, it's a no-go.
It's a no-go, and that means you have to go through the trucks again and adjust the side frames, clean out the journals, lubricate it, whatever you have to do to get it to roll. And like I say, we don't really like to see everything roll at 0.5% or less like that. What I'm really looking for here, and what most cars do, is they'll roll on 1.5% in that neighborhood. Now that's a good range.
Okay, so now we've got all our 4 axles are gauged properly. They roll true. They spin well in the side frames. And
Right.
so now what's next?
So now what's next is we're going to put the trucks back on the car, and before we adjust the trucks properly for rotation and free play, we're going to do the surface plate test.
And this is to make sure that it's resting on all 8 wheels.
This is to make sure that the car is sitting square on the trucks and that all 8 wheels are going to make contact with the rail. Now, we don't do it on a rail because with the flange involved and with a rail you can't see anything.
Right.
So since we have machined surfaces, all these flanges are machined on the wheel, same as the tire. That we've already checked with our gauge. We know that's either good or not. So these are good. So what we're going to do is you need to be able, even though you don't run them this way, it's very important that you be able to tighten your trucks up enough with the truck screw that the trucks do not rotate, or at least not rotate freely. That's so that they're tight.
Pulling, so that way you're pulling it up against the
pulling it
surface,
up against
the bolster
surface,
surface.
the 2 mating surfaces, the truck bolster against the body bolster. And then you put it, you should have a piece of glass, a piece of Formica like this is good if you know it's true. And you also want to make sure, if you're using your workbench, that you clean all the glue and crap off of there so that you have a good flat spot. You want to have a light behind it and a bright surface, so when you get down and look between the wheel and where the wheel is supposed to meet the surface plate, tabletop, whatever you have, glass plate if you don't have anything else, you should not be able to see any daylight between any of the wheels and the surface.
Okay, so now we've verified that this car, the bolsters are flat. Okay, what's your fix-it if you got a high wheel? Suppose
That's a whole nother story. You're talking about either remachining the. Usually it's not the trucks. You can check the trucks to rule that out, but 9 times out of 10 it's the car body. Our cure is to put a cutting tool in a drill press, and since we're dealing with plastic and not metal, and to just run it under the cutting tool by hand on your flat surface. Use your drill press as a milling machine. Have the drill press locked in position at the right elevation. You have to fit that up. It's easier than fixturing everything and doing 2 setups because you have 2 bolsters. But with one good setup and a little WD-40 sprayed on the surface and a car against some square piece of metal like this, machinist square, whatever, you can, with the trucks off of here, you can put it under a cutting tool on a drill press. You have a milling machine, you know what to do. But anyway, drill press, just pass it under there, or better probably is to set it here, and if you can fix your drill press elevation without affecting the swing, then do that. Most can't, but it can be done, again, with a block like this to fix the elevation. Otherwise, fix all of that stuff so it doesn't move, and move the model under there. Grind off that piece flat. Do the other end, because otherwise one end's going to be higher than the other. And then put a new bolster on there. A new bolster exists in every KD number 5 coupler pocket. The lid, cut it out with a paper punch, and you have a bolster.
Now, when you say bolster there, that's the little raised
It would
portion
be
that centers the truck.
Yeah, we call it a hat section. It looks like a short, basically it's a cylinder coming through a flat plate, so it's a bolster plate.
Now, you told me that there's another way you can adjust it using shims you glue down?
I use sector shims, and that's a lot easier if you don't have access to machining or a drill press or a way to fix it. And actually, for me, while it was initially harder to do because I had more machine experience than hand fitting experience, it was harder for me to make the sector shims work because I had to figure it out. I had nobody to show me how to do it, so I just had to say, what's going to make one wheel come down and not the others? And say, well, obviously it's up too far, so it needs to come down, so you put something under that part of the bolster to make it come down. And the way you do that is, when the car is sitting there and you have the one wheel not making contact, before you pick the car up, so you don't get confused, get yourself a piece of chalk, colored pencil, or typewriter correction fluid, whatever, and mark the journal of the truck that is not making contact, so that when you turn the car over, or if you turn it in for end or whatever, you don't lose track of what you're fixing. When you look at the truck, if it was, say, this wheel here that wasn't making contact, because I have my mark over there, then I know the sector on the bolster shim is going to have to be the one nearest that wheel. And the way I do that is, we know that this is a round plate under there, so you can visualize, just like where that screw is, you have a round plate a little larger than that screw underneath it. A sector shim is going to be just that. You take a KD washer shim, 10 or 15 thousandths is appropriate, or you're going to have to do it by trial and error to fit it. Cut it in quarters, cut each quarter in half so that you have 1/8 of a washer. And what you'll do is, when you take the truck off of here, it will be positioned on that plate like a piece of pie, with the point pointing toward the screw hole, and the wide part closest to the wheel. And you'll position it on that plate so that that sector, the wide part, is right under where the wheel was. So you have this pie-shaped wedge, which is 1/8 of one of those washers under there. Now, then you put it together dry, no glue or anything, screw it down and screw it tight so that that doesn't come out of there. And then you turn the whole thing over and check it again and see if that fixed it. Or did it overcorrect? If it overcorrect, you have to use a thinner one. If it undercorrected, you're going to have to add to it. How do you know how much? Experience. How do you get the experience? Trial and error. So it's very simple. It's not rocket science, but you have to fool with it. I was so frustrated when I first started doing that. I was always machining things, but then I was down here one time, and before I had the drill press, and I said, I must try the sector shim just because it's so simple, and everyone else could do it, because not everyone has a drill press or a milling machine. So once you fool with it a little bit and you see how it's working, it's like doing it in the mirror. Everything is backwards, so always mark the thing before you turn it over. And put the shim in there. Once you have successfully fitted it and it solves the problem, take the truck off carefully, make sure the sector shim is where you want it, glue it on with some super glue, let it dry, put it back together, recheck it, and then make sure afterwards that you adjust your trucks for rotation and free play.
Okay, so now that we've either that the car is flat, or we've flattened it, or we've shimmed it, we
Right.
want to have the proper rotation of the truck.
Right. What you want is, you want your truck to be loose enough to rotate without binding. And a lot of people they'll see me do that, and they'll get a screwdriver or a hobby knife or something and pick it up and say, well, it's free. Don't make that mistake. Anytime you get something with any mass, any weight, any heft to it in your hand, that's what you'll feel, because this weight of this is greater than the resistance in most cases that you're going to find. So you want the lightest, longest possible thing you can find. Barbecue skewer is great because it weighs practically nothing, It's a long lever, so it magnifies any resistance. And while this looks to rotate freely, I can feel a lot of resistance in that wheel.
And what you're feeling for is that there's a little bit of resistance or none at all?
You want as little as you can get. You want none if you can get it. The trick is you want zero resistance while having almost no rocking from side to side like we have here. Now, you have to have some motion. And I will say there is a theory in the hobby that what you do is you tighten both of them and you back them off until one is really loose and the other one is not quite so loose, and theoretically neither one of them is too tight to have any resistance. And that theory says that, well, now you've formed a three-pointed plane by having this tight enough for it pivots on one contact point and this is pivoting on two contact points. I think that's nonsense, because this stuff isn't made that precision in the first place. And while it might work, and some trucks are actually made that way with points on the bolster, certainly that does work. What you really want is both of them to be as loose as possible with as little cross motion as possible. You got to have some. Now, this one actually, I have a lot of cross travel here, probably too much. I certainly wouldn't want more than that. How much is it? Well, it's a little bit. What can I tell you? This one has less, but I'm still getting resistance here. So the problem is, what do I do if I have this so loose, and how do I know it's too loose, and how much is too much resistance? Well, first of all, it's too loose if when you put the car up and do a tilt test like this, if the car will sit there and still shake back and forth like this after the wheels have hit the tabletop. I mean, this hits and it maybe bounces back a little and it stops. That's okay at one bounce back. But if you drop it and it's still moving back and forth like this for 2 or 3 times, the trucks are too loose. We don't want that. It's unprototypical motion. I mean, you do get rocking on a freight car, but not at that frequency. So this doesn't look right. So then it's a matter of tightening and loosening. If that doesn't do it, you have to consider the fact that if you have put your truck screw in there and over tightened it, you could be mushrooming that little bolster hat section down against the sidewall, the inner sidewall of your truck, so it's binding. So the cure for that is you have to take the truck off and trim with a file the outside or a piece of sandpaper that hat section where the screw goes through, so that it's not rubbing the inside of the truck. A lot of people will go and trim the inside of the truck with a rat tail file because it's easier, but really that means you can never use that truck on another car should that ever happen. I prefer to do it on the car. Solve the problem at its first point. Don't solve the part that can be used on another car if it's reclaimed later. And that's probably not a concern for most people, but we do wear stuff out, so reclaiming is a consideration for us. So,
okay, so now what you're saying here, as I'm understanding, is that if the hat section, if the cylindrical part of the hat section is too tall, so the screw hits that before it hits the truck when you're tightening up, it will deform that piece.
Yeah, right.
And so you really want to trim that hat section down before you even start tightening it.
You should.
Right?
The real test, and this car doesn't really have a defined hat section. This is a kind of car that has a very minimal, not even a proper hat section. But what you do is you look at your truck, and when you put it on the car, that hat section that comes up through the inner part of that truck should be below the lip of the truck itself.
So you want to do that before you tighten it down.
You really want to do that
time.
before.
Okay,
yeah.
and that way you avoid the mushrooming problem.
Right.
Okay.
The screw hole itself may vary a little, and the screws vary. The other thing you have to watch for, probably the biggest mistake most modelers make when they're assembling a kit, most of these kits nowadays don't come with machine screws, they come with sheet metal screws. Bad idea, because what happened is the machine screw has a very fine edge and a very minimal angle to the spiral. The sheet metal screw is very coarse in comparison, has really deep, wide-spaced, steep-angled threads. Now, when you put that in the plastic, it's going to want to pull that thing as you screw it in off-center. So what's going to happen is your screw's not going to go, even though it's going into a hole, the hole is not hard, it's plastic, and that screw is so sharp and strong, it's going to deform as it goes in there, and it's not going to run true, at least for the first 3/4 of its depth, or maybe till it bottoms out. The screw will not run true in a hole because those coarse threads will pull it off. You have to really watch from all directions, make sure that the screw is going in there straight if you're using one of those kind of screws. That's why I prefer to use a machine screw and tap it. You can buy those taps. KD sells kits with the, they don't have a tap holder, you buy that in a hardware store, but the tap itself for a 256 screw with the appropriate drills you can buy from KD. So what we want then is a happy balance, which I think we have on this car. And there again, everything you do, check it. Even though we've checked all of this and put together, now let's make sure we've got the effect, everything is right. We know that the trucks turn, the wheels turn, everything is happy. Let's, again, make sure we haven't done something, knocked off our sector shim or over tightened or something. Make sure that all the wheels are on the ground, everything turns, everything works. And put it on the test track. We're getting into the next thing as we come up the car. We've done the wheels and the trucks. The next thing we're going to do is check the couplers. And before I do that, I'll have to tell you about the coupler gauges. When you have a gauge is a standard against which you're going to check everything you do. You should always have two gauges because you want to compare your two gauges and see, do they check? And I would say, well, what's the tolerance? So tolerance should be as little as you can get. I mean, they should be as close as possible. They come several ways for several size coupler heads. The 58 is a finer scale and the 5 is the coupler we're all used to. So here is the 58, which is a little more scale appearing, although none of them are true. They're all very little. And here's the other one. And when you put them side by side, you can see that there can be a relative difference of 20 to 25,000. Okay. You're not comparing the bottom of the coupler or the top of the coupler. You're really comparing, you want to compare the shank, assuming they're all the same. And if they're not the same, the only place that you can compare them where it's going to come out the same is going to be on the center line of the shank. And fortunately for us, there's a parting mark or casting mark on every knuckle that shows you where that is. There's the horizontal line there. You can highlight that a little bit with a file, so just file the black off of that, as I've done here. There's a little line across here, because when you compare couplers, you're going to have different head heights, and you want those center lines to line up rather than the top or bottom edge of the coupler. So once you've established you have a good gauge, now you can check the car. First, a good test for any coupler is make sure the coupler is where it wants to be, because the spring inside can affect it. Those little fingers that press on the side of it can actually make the coupler go up or down depending on how they're aligned and how they mate with the surface, the banjo section of that coupler. So you want to make sure the coupler is going to be where it wants to be. So, and it's pretty straightforward. Put the car on the gauge, make sure the gauge is not rocking, is on the railhead properly, and you can put the two together. Here we see this coupler is quite considerably low on this end. The cure for that, for a lot of people, is just to simply take the trucks off, put a shim in there, which KD makes, and raise the whole car up by that much.
Right.
The trouble is, that is a lot of elevation change. And what you really have to do is be familiar with your equipment and the prototype you're modeling, and have available to you photos where you can look at this and say, is that going to make the car sit too high? And this car really is what we call, it sits high anyway, even though it has a fish belly underframe which hangs low, that the car basically looks like it sits high on the trucks, and they look like that. So putting those washers under there to get us this 20 to 25 thousandths that we need is not the answer, and that's why this car is in a bad order track. The real answer is to take the couplers off and remount them, either by adding shims or removing shims or thicknesses by whatever method works best for you. In the case where the coupler is too low, that means the coupler has to go higher in the car, so that's a harder problem to solve. If it's the other way, it's simple, you can use shims. So in this case, I would look at taking the coupler box off completely and either doing some machining, filing, whatever they're fitting, maybe consider a different coupler box or whatever, but it's going to be trial and error to fit it, but we know they're low.
And how about the drooping coupler problem?
The drooping coupler problem is pretty easy to fix because you can actually fix it. If you do it right, you can fix it without taking a coupler apart. If it's just a droopy coupler, and sometimes you have excess free play in the coupler relative to the draft gear box in both directions. So not only is it droopy, but you can push it up so it's too high. So what you want to do is insert a shim in there without disassembling the coupler. I use HO scale 1x2 lumber size, which you can get from Evergreen, and this is all way oversized. The 1x2 is going to be very, very thin, you know, 10 thousandths. And the proper way to do this is you do a test fit. Don't cut the piece, just take the whole stock and stick it in the draft gear under the coupler. Test fit it dry like that.
So what you're going to do then is basically take all the vertical play out of the
Almost
thing,
all of
the
it.
pocket's too deep for the shank.
What's probably happened in most cases is if it's not a new car, is that the coupler box lid is worn, bent, whatever, from use, and they just acquire more free play over time. Now, for people that got a 4x8 layout, their lifetime, they probably won't get that much free play. But we do a lot of miles here on our railroad. So whatever your shim is, you'll test fit it and see, will the coupler still move? I tell people to cut your shim so that the length is 3/4 the width of the box, because you don't want it to go from corner to corner. Because if you do, the couplers always jam in the corners because the clearance is tighter. There's a little, actually a saddle or a sag in the middle, so you're going to put your shim there. You might even have to take a file or piece of sandpaper and dress the corners of your shim once it's glued in there. But I just typically cut the shim to that length, 3/4 or maybe 60% of the width of the pocket, stick it in there with a pair of tweezers, locate it, hold the coupler down with my finger against the shim. Once I've got the shim in there, take a drop of MEK or super glue on a pin, something very small, and just touch it to that shim. Let the capillary action draw the liquid cement in there, and hold it there till it's on its way to setting. Hold it for 10-20 seconds or so it's got a grip on it. Then set it aside to dry. Do both couplers. After you've done that, if you find one of the couplers is glued to the shim, usually you find you can just break it loose by putting your thumb against the coupler and moving it. 9 times out of 10 the coupler will be loose, the shim will still be intact, and now your problem is fixed. If you still have a problem, you're just going to have to do more messing with it. What else can I tell you? it's more of the same. And so you can see where the shim is.
Yeah, right. So now we have, how much free play do we have here? Very little, almost zero, which is about ideal, and the coupler still goes. So now let's check our gauge again with that coupler, see if that did what we wanted.
If you can shim it out by putting a shim over it without taking the coupler box apart, by all means do that. But if you can't, or it droops too much, or it's raised too much where your surfaces are no longer quite, perpendicular to each other when they're coupling, what you want to do is take the truck off so you have access to the coupler, take the whole coupler box off and put a shim in there. Now there again, you have to have some idea before you start how bad is it. If it looks, just hold a KD washer there. If it's a 10 thousandths, you can see from the 10 thousandths washer. If it's a 15 thousandths, you can see from comparing against a 15 thousandths washer. That's your comparator. Look and see what it looks like. If it's more than that, then double them up. If it doesn't quite work out, put the thick one against the thin one and double that up and put it there and see what it looks like. Get an idea what you're dealing with. The KD washers cut up like we did with the sector shims make perfectly good shims also for coupler shims if you don't want to use this. What I like about the styrene that's better than that is styrene is slicker, but as the styrene wears it'll get rougher. With the fiber washer, cut sort of like a sector shim, you'll be cutting it maybe in thirds for a coupler application for a shim, and you can use them above or below it. The good thing is they have a radius to them because they're cut from a circle, just like the movement of the coupler is on a radius pivot point, the screw. So they fit in the mouth very nicely.
So it sounds to me like what you're saying here is that what you're aiming for is a difference of the center lines, the horizontal center lines vertically aligned,
Right.
of less than 10,000ths of an inch, which is a thin KD washer. Is
Right.
that what that's sort of your tolerance?
That's the neighborhood where our actual tolerance is 1 washer. It doesn't specify the
Yeah.
thickness, because if you're using a 58 coupler, you're going to have to get a different material, because actually even a 10,000th is going to be too much thin. Now you got to remember, since the 58 coupler is 20% smaller, all your tolerances have to be 20% finer. So
Okay. Right.
there you go.
Okay. One other question.
Yeah.
How do you address the mechanics of attaching the coupler to the car, given that we pull long trains here, so we're pulling pretty heavy drawbar pressure?
We like to mount them only with 1 screw, the center screw, because 1 screw is easier than 2 screws. If you're going to use 2 screws, some people will put actually 2 screws in here and no center screw, but that's a lot of work, because both holes are smaller than your 256 screw, and your margin for error is much smaller, and they both have to be located pretty precisely. The other thing you don't want is if you have any daylight, and daylight, it means you can see through there. You can see through this space or past something between the space between the end of the underframe and the coupler box. That space must be filled. And if you don't fill it, what's going to happen is eventually that screw is going to loosen up, and out there in train you're going to get your coupler box is going to rotate. Let's see if I can get this one to rotate. This one's glued down and it's not going to. So that's your alternative. You can glue it. Glue may or may not hold. If you use super glue or MEK, MEK will bond plastic to plastic, so if it's not moving, it's probably not going to. But I also require that visually this space be filled, so when the car goes by you in the train at eye level, you don't see a break between the underframe and the draft gear, because in the prototype there is none. It's all one.
So you want the coupler box to be securely butted up against the bottom of the car.
If it's not, you need to have a spacer in there to fill that up. If you glue a spacer in here to fill that visual space and prevent that mechanical rotation, if you glue it to the coupler box, if you ever have to do maintenance to the coupler, that can be a problem. So when you glue that in there, you want to, if possible, glue it to the underframe and not the coupler box. But you want it tight enough where you don't see daylight.
Now, going back to attaching the coupler in the first place, where
we require here that it be attached with a screw, a number 2. We say a number 2 or equivalent, because I think that's what the NMRA rigs say. So if you wanted to use 80 screws or something, assuming that I think the most important thing with no matter what size screw you use is the screw is small enough so that it does not destroy the coupler bolster, does not interfere with the movement of the coupler, swing of the coupler, you don't want the screw so tight or with so small a head that it crushes or deforms either the box or the lid. You want the screw to be what we call here a functioning screw. That is, it can't just be the depth of the box. It must actually go through the box and into the car body, the floor, or whatever it takes to secure it. People ask me all the time, does it have to go into the weight? I says, well, if you have stripped plastic, or you're only going through 10 or 20 tons plastic, that's one thread. That doesn't secure anything. You're pulling a whole train on it. So no, you may have to. Every case is different, but it has to be secure.
Have you ever done a test when you've got a 100-car train or a 70-car train, what kind of drawbar tension we're pulling?
With the trains we run here, you can get 5 pounds pull, no problem, especially starting it.
And all that's being transferred through each coupler screw?
All that is being transferred through every coupler screw and every coupler, or it's less, every car you go back in the train it's a little less, but yeah. In the old days, we don't do it much anymore, but in the old days, we used to physically tear out couplers and their draft gear and break knuckles and all of the above. And you'd find, at the old Mesa Club, you'd find knuckles and couplers and screws and pocket portions littering the right of way. And when we first came in this building, it was that way too, but we've since learned a lot.
Has the manufacturing of couplers improved the quality of the material so they don't break, or what's happening there?
The material hasn't, I don't think so. I mean, there's a lot of engineering plastic, I think, now being used to make plastic couplers. We find basically plastic couplers don't work for us because if they don't break, then they flex too much. It's a real problem when you start coupling locomotives and long trains together. It just magnifies every difference in coupler height. And the trouble is our couplers tend not to equalize like the prototypes do. You get a prototype coupler and you get it in a train, and anytime the slack runs in and out of the load changes, or you pull really, really hard on the coupler, if they're misaligned, you have so much strain on there that they will align themselves because the stress will follow the shortest line, which isn't a bent line or kink line, it's this way. So prototype couplers, and they'll go bam, it just sounds like dynamite, and they'll equalize. But the model, they'll take the set to wherever they were when you took the slack out of them. So if they're like this, if the springs make one ride up and make another ride down, then you get a coupler that does this. And with plastic, once they've started this way, as they start up the hill, the strain on them just increases and they just will slip right by. The shanks will bend and they'll but just slip by. Metal coupler generally won't do that. And since we tend to shim everything, the vertical free play out of it, it's not very much of a problem with metal. It's just, well, basically it isn't a problem. And that's why we use the metal couplers.
And now we're talking about weight and the tilt.
Okay. Now, first I'll do the weight. We expect you to adhere to any NMRA regulation or standard RP, recommended practice, that is not exceeded by one of our own. We started basically the same weight as the NMRA, but we found on this mountain railroad we were burning up locomotives. Like for a 40-foot freight car, you'll see the weight is in the same range as NMRA. I won't say identical, because it was at one time. It's basically a 40-foot car with always 4 ounces. What I've done in recent times, in years, we've worked our whole fleet at being, let's make them lighter if possible. When I compared cars, I could get 2 40-foot cars, and they both rolled well. But in the train, one of them would cause derailments and the other one wouldn't. I checked the wheels, the gauge, the trucks and all that, no problem there. Turned out the problem was the propensity for very heavy cars, in this case a 7-ounce car, 40-foot car versus a 3.5-ounce 40-foot car. The heavy car, due to the placement of its weight and resultant high center of gravity, the car wanted to string line or roll over. I needed a way to quantify the NMRA rule that we adhere to that says that any supplemental weight added to a model must be added as low as possible. Now they say right in 25.1 or whatever it is, it's in there in their weights. They don't give you a way to quantify it. So thinking back in my geometry and brainstorming with Rick Fisher, says, let's use a protractor. So we came up with a movable protractor. Like any tool, and like I said before, you want to check this and make sure you got 0 against the square.
So you're checking this after you've adjusted the truck swing, or do you tighten them up?
I actually do it with the trucks tight, not tight. I'll say not loose. I mean, I don't want any free play this way. I want the trucks just to barely swivel or not swivel at all, because what I really want to test is see what's the furthest it'll recover from, and is it the same on both sides. So when you start, the first thing you do is just check and see, does the gauge read the same way on both relative sides of the car? You know, and if you check this at the door, you better check at the door on both sides. If you check it at the ice platform at the end of the car, you better do the same on both sides of the car. Make sure that you have true 0, or if you don't have 0 and one is 1 degree, the other end should be 1 degree. You don't want one end on 1 degree and one on 3 degrees. That means you've got a twisted underframe. If you have 1.5 degrees or more difference, that car will always cause problems. Always. The car is going to derail. It's going to cause others to derail. Once you've got to where you've determined the car is sitting vertical, or very nearly, then you can do the tilt test. And the thing with the tilt test is we want to see the furthest deflection it will recover from. And what you do then, when you check your reading with the other side. So I'll go to the other side and do it. It does the same thing. So I can see in this reading on here, what I'm checking, this is 45 degrees, which is about as good as you'll ever get for any kind of house car. Now this car didn't get that way because the manufacturer did such a bitchin' job. It gets that way because in addition to the weight we put inside, which was probably not the manufacturer's weight because those tend to be too thick and too high. We use thin sheet lead to fill the whole floor, and then this has got sheet lead down the middle of the underframe.
So you've, to fill the floor, you mean underneath you've added?
Inside the car we have a full width floor weight that's fairly thin, like 25, 30 thousandths. And then
Is that
here
lead or steel?
it's lead. I prefer to use lead because you can drill it. I will use steel, but the problem with steel weights is usually they're not uniform, they're stampings. And if you start out using for example, using an Athearn weight in an Athearn car, they will change whatever cutoffs they're buying from some manufacturer, and that's what they're buying is cutoffs. They're not buying car weights, they're buying cutoffs and using them as car weights. So the ones that they make next week aren't the same as the ones they ran last week, so they don't fit in the car the same. So what happens is, since they're not full widths, they don't center. If you have a full width, you eliminate the centering problem. That's why I use lead. I can cut lead. I can calculate, a 1/8, if you take a 1-inch square of lead, 1/8 of an inch thick, it weighs 1 ounce. From there on, you can do the calculations in your head about the thickness of lead and how many square inches you need. Once you figure out what the weight should be and what the result is on here, and you can do that by basically taping the weight underneath the car, then you can put it together. Some cars require the additional weight underneath, some don't. Some cars do better with most do better with a full width weight inside. Some don't because of the geometry between the truck bolster and the body bolster, and the difference in heights, because this is not uniform in HO. They're different. The geometry can be different enough where sometimes a wide or a narrow weight might work better in some cars than a wide weight. You have to do, that's what's great about this. I can do an A-B comparison right here. And if you have a car where the roof pops off, which this one doesn't, but a lot of them do, it's just simple to do it. If a car hasn't been registered yet, it's not put together hard. It's not, we can take it apart. Once it's gone through all of this and it's cemented up, that's pretty much it. But it's been determined, it's been worked out. So we have a CG of 45, and we make sure that it is within 5 degrees of the tilt, as opposed to the 1.5 degree vertical difference.
You mean on either side?
On either side, we make sure that the reading from one side to the other is within 5 degrees. If it's between 5 and 10, I'll look at it close and see what it has a tendency to do, and I might allow it. But certainly beyond 10, it's a mandatory adjustment. You have to add or remove weight from one side or the other of the car on the bottom, or wherever you have to do it to equalize that so that they're more the same. Because you don't want, we take the poorest reading as the index for the car, and you don't want a great difference from one side to the other, because you don't want to go around left-hand curves and not right-hand curves. So you want them the same. And so that's kind of the way that works. And I will say that our minimum standard for center of gravity for deflection is 30 degrees deflection from the vertical is a minimum for any car.
At this point, when the car's all put together, there's no real way to get in there and eliminate weight without tearing it apart,
That's
right?
why I tell people, when you're building a car, the scale is your friend. You pile all the parts on there and see that you're getting close. You want to be within a quarter to a half an ounce either way of what you're getting to. And then before you finally button it up and glue the top on or glue the floor in or whatever, you can still do your tilt test and all that and adjust things.
And how are you securing the weight these days? I mean, do you...
It depends what it is. On a car like this, typically it'll be secured by, it'll be a lead weight glued on the floor inside.
What do you glue it with?
These days I'm using super glue. My preference, if I have a large plate and a large floor and it's a tight fit, I use the super glue because I can clamp it and get a good flat, a large surface area cementation. And you could use rubber cement and stuff like that, but I don't like that because it tends to dry out. I haven't had a problem with the super glue drying out over time. The only thing bad about super glue, if you drop the floor, the shock can shear that joint. It doesn't have a lot of shear strength that way if you have a strong impact. But on the other hand, if you do that, you probably trash the car anyway. I use an awful lot of automotive silicone rubber because it shock mounts the weight. I tend to do this if the weight's like, for weights, smaller weights I put here, and I tend to try to partially encapsulate the weight. Anytime I use the RTV, I try to partially encapsulate the weight, that is on 3 sides. And if I have big weights in there, like if I have big chunk weights like you might have here, I'll put a band over them. So if it drops, and the thing I found with that, with the RTV, it cushions the weight a lot more, and even if the car hits the deck, if it's still usable, if you can fix the body parts, the detail parts, the weight will still be good. Our weight table, we have a table that goes by car body length and rollability. If you're building a car, before you start putting it together, take all your car parts, and if you have a lot of little detail sprues of plastic parts, don't worry about them. If you have 4 detail sprues, just put 1 on there and leave the rest of them off. Because the only thing that weighs anything in the parts, the sprue we don't care about. So just lay 1 sprue on there. But all your major parts, trucks, couplers, body, weight, roof, and all, put that on the scale, see what it weighs. Make sure it falls within the tolerance before you start building it of where it should be. If it's not going to fall within that tolerance, then you're going to have to make the rollability really good to go for an allowance, and it's going to have to earn its allowance right here on this tilt table, because this is the way we grant them. Because what we found is, it's not the weight, it's the rollability and where you put the weight, and that's the big factors.
Okay. All right. Well, I think that about does it. Thanks, John.
Okay.